Hello and welcome to this Aviation Week talk on the advanced air mobility market. Rebecca, next slide, please. I'm Graham Warwick. I'm Executive Editor for Technology at Aviation Week, and this is a bit of an experiment. I was putting together this article, which appeared in our first issue of this year, and I decided at the end of it that it might be of some value to our subscribers and audience to have a sort of a bit of a discussion about the advanced air mobility market, because it is changing so rapidly and it's very hard to keep up with it. So I just thought I would take the time out and try and sort of give my view, at least, of the AAM market. So this is a little bit unusual for an Aviation Week webinar in that we don't have a panel up there along the top of your screen. We just have me and my producer Rebecca in the background, who I'll be saying next slide to from time to time. But luckily I like to talk, so I will be able to fill in the time. So Rebecca, let's get started. Next slide, please. So AAM, Advanced Air Mobility, what is it? Well, it's not one thing. That's the most important thing to realize about AAM. It is a mix. It is passenger and it's cargo. It's piloted and it's unmanned. It's commercial and it's military. And it includes, in its broadest sense, it can include things like infrastructure inspection or medical evacuation. It's a very broad category. It covers a broad range of markets as well. Obviously, we started out talking about urban air mobility. We now talk about AAM, but it's urban, suburban, which is commuting. Urban's, flying around within a city. Suburban, commuting. Rural, connecting the countryside with the cities. Regional, intercity, in other words, connecting the cities. And then we're seeing the emergence of military roles such as logistics and other things like that would use the same technology. And the thing about AAM is it's founded on a kind of a common set of technologies that are being used in slightly different ways in each of the different missions and markets. And those technologies are fundamentally electric and distributed propulsion, i.e. not the conventional, monolithic one or two engines, but some sort of a more complex arrangement. Fly-by-wire flight controls are a big part of this, which enable greater degrees of automation, simplified operation. Connectivity, this is all enabled by being able to app-based services, and over time, greater and greater autonomy, which is key to the economics of advanced air mobility. So I would say that the characteristics of AAM is it's not traditional aviation. This is not replacing a form of aviation that exists today, by and large. It is competing with cars, trucks, buses, and trains for moving people and goods around. I would also say that by and large, it is also commercial aviation. There is some personal aviation in this. There is some general aviation, more traditional roles for helicopters, etc. But fundamentally, we are talking about commercial air transport on a different scale. Next slide, please. And it's part of this, as we're all seeing in our lives, it's part of this wider rethink of transportation, redefining it as mobility and moving from thinking primarily about vehicles to thinking more about services. So, we see examples every day of micromobility, e-scooters, ride-sharing services using your smartphone app. And over time, we're starting to see, penetration in the market of self-driving vehicles, which could really fundamentally change the way we use cars to get around. And it also includes, drone delivery for packages or medicines, and it also includes, beginning to include some much more exotic options such as supersonic and hypersonic transport, and even suborbital transportation. So, next slide, please. So this term AAM's come up, and we were talking in terms of UAM. So what should we be calling this? Well, as I said, it is AAM is more than one thing. So it does encompass urban air mobility, which is flying around within the city. It does encompass regional and sub-regional air mobility, which is short-range intercity flying. it does involve logistics, which can go from small drone delivery of packages all the way to moving, freight at regional ranges, what they call the middle mile transportation market. And it includes the military, and we're seeing interest in AAM vehicles for things like base security, flying guards around, these very large military bases. To even the possibility of personnel recovery, where you might drop them into a vehicle into a downed airman somewhere, and they'd be able to fly themselves out of contested territory. Technically, aircraft-wise, AAM involves electric VTOL aircraft, vertical takeoff and landing, but it also involves electric short takeoff and landing and electric conventional takeoff and landing. And in each case, the E, it means electric, but it can mean all electric, hybrid electric, or as increasingly we're hearing about hydrogen electric propulsion. So next slide, please. So how big is this market? Well, how big could it be? So we have a couple of recent forecasts here, one from Roland Berger in November, which put the passenger UAM industry, said it could generate annual revenues of 90 billion by 2050 and involve 160,000 commercial eVTOL vehicles flying around. Now, they were talking about what they call passenger drones, but which is really, we can think of as the sort of the passenger air taxi market. So the most recent one, which came out this week, is from Deloitte and the Aerospace Industries Association, and they put the US AAM market, which is a wider market, not just UAM, but AAM, they put it at, it said it could reach 115 billion annual by 2035, which is bigger and quicker. But that's split between cargo, roughly equally split between cargo and passenger, although at the time of 2035, passenger is starting to grow much faster, so they see greater growth in passenger. And if you look at Roland Berger, they took their passenger UAM and they split it pretty much evenly between inside a city taxi services to and from the airport, shuttles, and then this inter-service, more regional routes. But I think that just says that we don't actually know how big it is. It's in multiple triple-digit billions probably, but we don't quite know how big it is. And also, how big is that? How big it is. The global airline revenues before COVID hit in 2019 were 840 billion, so it's smaller than the airline industry was in 2019. It's also a lot smaller than the ground taxi market, which is supposed to get to 300 billion by 2030, and a lot smaller than the overall public transport market, obviously, which is projected to be $1.1 trillion in 2030. But, and here's the important but, it is bigger than the helicopter market. And that, I think, is one of the key reasons why there is so much interest around this market, because it does look like we have the potential for an aviation market here that is bigger than two of the traditional aviation markets, both the helicopter market and the sort of the more general aviation market. We do have a potential here to create a pretty big aviation market over time if this happens the way we think it does. How big is it now? Well, you could say it's zero because there are none of these vehicles in service now. It's not quite zero, as we'll see, but we are seeing that even though the revenues are not yet there, the investment is. We're seeing startups took almost $1 billion in investment in the first half of 2020, and that was many times up what it was. And the caveat on the zero is there are people doing urban air mobility today. They haven't called it that till recently, but it is urban air mobility, and that includes Blade in places like New York, who do helicopter services. And obviously Blade has just announced a merger with one of these special purpose acquisition companies, which allows them to go public. And that valued Blade, which is not that big an operation, but at about 825 million. Now they are now going to take that money, the investment they get, and grow. So you are seeing the beginnings of a market of some potential scale. Next slide, please. And it is a market, as I said, it's already bringing in the money. And so if you look at the investment into the AAM market, China's EHang, which is really, like the sort of the leader in getting UAM moving, they went public in December 2019. They're the first to go public. Joby has raised about 820 million, which is pretty impressive. There's some rumors that they may merge with a SPAC to go public, but they're not saying anything. And that puts them up about that 1 to 1.5 million that people think is necessary to certify a vehicle. And then since they plan to operate their vehicle, they probably have to raise a whole bunch more to build a fleet and operate a fleet of air taxis. Lilium in Germany, they're at 376 million announced so far. There's been rumors about them merging with a SPAC to go public. Volocopter, another German startup with a simpler vehicle, has raised about 144 million. Belief is they need to get some more to get to market, but they're marching along. And then you've got a whole bunch of people that are supported by high net worth individuals, Archer, Kitty Hawk by Google co-founder Larry Page, etc. And then we have started in the last couple of years to see the US Air Force put some money, small amounts of money, into the market in the form of small business contracts to do testing and prototyping and develop technologies. We've seen them put money into Joby for prototype testing, Beta, Lift to provide aircraft to fly, and to Elroy Air to develop its cargo aircraft. So, and we've seen this big interest from the automotive market, who are redefining themselves as mobility companies. So air mobility, they think, is an extension of what they do. So we've seen Toyota make a big investment in Joby, providing a lot of its manufacturing expertise. We've seen Daimler was an early investor in Volocopter. And Fiat Chrysler, sorry, I spelled Fiat wrong. Fiat Chrysler has just tied up with Archer to help it with the manufacturing side. No indication of investment, but certainly a manufacturing tie-up there. And Geely, which is the Chinese car maker that owns Volvo and Lotus, they are investors in Volocopter. They also own Terrafugia, and they're doing their own eVTOL work within Terrafugia. And I didn't put it on there, and I should have done, is South Korean car maker Hyundai, which has said it plans to spend 1.5 billion developing UAM as part of a multimodal approach to mobility. Next slide, please. So feel free to ask questions as we go along. I'll tackle them at the end if I don't talk all the way to the end, which I'll try not to. So as you're probably aware, if you've paid any attention, this is a market with a lot of people who want to play. And they want to play in different parts of the market. As we said, it's not just a one color of market. So in the UAM, i.e. eVTOL market, we have China's EHang. I've mentioned Joby and Volocopter, Wisk, which is a joint venture between Kitty Hawk, privately backed Kitty Hawk and Boeing. Hyundai, I mentioned Eve, which is a spin-off from Embraer's market accelerator, Embraer X. Jaunt Air Mobility, Vertical Aerospace, which is a UK startup, and there are many more. In the regional air mobility, where we're looking at doing this intercity flying, we have Beta Technologies is looking for longer range, initially oddly enough, for the organ delivery market. It's a very specific use case, but it requires long range, but that would allow them to move into the passenger carriage over time. And then you have Electro, which is a startup doing eSTOL airplanes, and Dufour, which is another Swiss startup doing another sort of like medium range airplane, looking at more than just the urban market. And then we go beyond the sort of sub-regional intercity to true regional services. We get into the hybrid electric aircraft like Ampere, Voltero, the hydrogen electric airplanes like Zero Avia, and then some other startups like Aviation, which is all electric. But they are looking at what we would more traditionally think of as regional aviation. Short haul still, but more recognizable as regional aviation. And then we've got this logistics, express logistics, middle mile market. We've got Pipistrel in Slovenia, which is already a leader in electric aircraft, is now developing an unmanned cargo aircraft. I've mentioned Elroy, there's Saberwing. Airflow is looking at an eSTOL, electric STOL version, which would literally take off and land from the tops of distribution warehouses and connect hubs and things like that. And you see some of the variety of shapes and sizes of vehicles that you get that are pursuing those different markets. So slide, please. So So AAM is not aviation, is aviation, but not as we know it. Was it? And eVTOL is VTOL, but not quite as we know it. And one of the reasons is there are so many different configurations that are being enabled by electric and electric distributed propulsion. So we've got the sort of the multicopter, which you could argue is a growth up from the sort of the drone market. And examples include the EHang, which is an early leader in the market, volocopter similarly, and City Airbus is in effect a quadcopter design. They are probably the simplest vehicles, but they require their rotors to provide both lift and thrust, forward thrust. So they're not as aerodynamically efficient, tend not to have the range or endurance. So they tend to be looked at for the urban, short range urban market. The biggest part of the market is this winged eVTOL, because what you do is the wing gives you the aerodynamic efficiency in cruise flight, so you can start looking at longer ranges, higher speeds, and start to offer more of a time benefit to the users, so they would be prepared to pay for the service. Examples are Beta, even Whisk all have they have that lift plus cruise, which means you've got a propeller for propulsion in forward flight and multiple lift rotors or lift props for vertical flight, and one operates in one mode and the other operates the other, and you transition between the two. Vector thrust is where you have one source of lift and thrust, and you just move between the two modes. You point it downwards to take off vertically, and then backwards to fly forward. So, but even in that category, we have many different approaches. Depends what you're going to want to tilt. You can tilt the ducts, you can tilt the wing, you can tilt the props, you can tilt the fans, and you can tilt rotors. So, Bell's Nexus is tilt duct, Dufour's is tilt wing, Joby is a tilt prop, Lilium is many tilt fans. And Overair is much recognizable as a conventional tilt rotor, but it's got 4 rotors. And then you have another category, which is where basically they've just said, we're going to put everything on this airplane. We're going to have tilting props for lift and thrust, and we're also going to add some lift rotors just as well. So you get these quite interesting sort of hybrid designs where that's one down in the bottom corner there, that's vertical. They have 4 tilting props and 4 stop fold rotors that are just for lift. So the thing to realize about what makes eVTOL not conventional VTOL is they have different characteristics to helicopters. They don't hover. By and large, very few of these machines are designed to hover. They are designed to fly for short periods in vertical flight, takeoff and landing. And that impacts the amount of power. It's why it's possible to think about battery-powered vehicles for short-range flight. They need a lot of power for takeoff and land, but they're only doing that for a very short period of 30 seconds or so, a minute or something either end. Still a challenge, but it does at least make it feasible because you're not hovering and using that power for extended periods of time. And the other big difference between many of these configurations, tilt wings, tilt rotors, tilt ducts, have been tried in the past with mechanical propulsion, turbine engines, shafts, you name it. And the result was a great deal of mechanical complexity in order to interlink everything to try and give the level of safety required. And of course, all that mechanical complexity led to poor reliability, or at least an impact on reliability. And many of those configurations really never caught on because of those sort of disadvantages. Now, when you look at electric propulsion and electric distributed propulsion, what that is bringing is you're greatly simplifying the mechanical complexity. You are using electric machines, which are inherently more reliable. You are increasing the electric complexity and the digital complexity, because these are very complicated machines, but you've reduced the criticality of each individual component. In a helicopter or a tilt rotor, almost every single component in the drivetrain is safety critical. If it fails, something bad happens. When you get to distributed propulsion with redundancy in the battery system, in the power controllers, in the engines, in the windings within the engines, you can have what appears to be a very complex vehicle, but its criticality is much lower, which means the care and attention that you need to pay to maintaining that vehicle, the cost of the individual components comes down dramatically because they are not individually safety critical. The system might be, but the individual components are of much less complexity. Next slide, please. And as I said, it's not just eVTOL. The thing about eVTOL, it's the most demanding case for electric powered aircraft, particularly battery powered aircraft. If you relax that requirement and say, I'll use a little bit of runway to take off and land, you can take the same battery, the same motors, the same everything, and just get more capability from them, because you're not sucking all the energy out of the battery in that last few seconds of the flight. But if you can get the short takeoff short enough, you might still be able to operate from the same sort of urban environments, urban airstrips, vertiport type scale of airports, yet fly much longer ranges. So you could do the urban takeoff, the regional range, on essentially the same sort of level of technologies as you do a short range. So what STOL allows, what distributed propulsion allows you is to use the distributed propulsion to give powered lift, so you get this super STOL capability to take off in really short short distances, take off and land. And a couple of there, obviously Electra on the left and Airflow on the right, are two companies that are exploiting that powered lift phenomenon to enable operations from either on the top of a distribution center or a downtown airstrip. And then obviously eCTOL, you can use all this technology in a conventional takeoff and landing aircraft. So there is a group of companies that are looking more traditional regional operations. We have on the right there, we have Heart in Sweden, and on the left we have Tecnam in Italy, that it's taking an existing aircraft, the Traveller, and converting it to battery powered for short range. And what that gives you is the lower operating costs of the simpler machines, the simpler electric machines, the lower energy costs of the electricity, and you get either, depending on whether it's all electric or hybrid electric or hydrogen electric, you get either lower or zero emissions. Slide, please. So how soon is all this going to happen? I won't go through all of these here, but if you were to look, you will see that between EHang and Lilium, you are looking at talking about entering service between 2021 and 2025. There's a lot of companies that are planning to begin air taxi service, or in the case of Elroy and the likes, regional cargo service within that time frame. They might not be in the most demanding of markets. It may not be in Europe. It may not be in the US. Within the 23s, it could be somewhere where the environment is more forgiving, but it could be. Lilium wants to start service in Orlando in Florida in 2025. And then you see another group of companies that come in. They start to come in around about the 2028 to 2030. Hyundai said 2028 for its air taxi. Airbus and Bell have talked about sort of by 2030. They're not specific, but you can see that certainly by 2025, there's a whole bunch of people who expect to be offering services, and that by 2030 there'll be a whole bunch more people. Next slide, please. So that's what the industry's saying. What are the regulators saying? Well, interestingly, going on at the moment, yesterday, today, and tomorrow is the Vertical Flight Society's Electric VTOL Symposium. It's a virtual event. And speaking on that yesterday was Jay Merkel, who heads the FAA's UAS and AAM integration office. And he said that the FAA expects its first UAM AAM aircraft to be certified sometime this year, with 2 or 3 others following. Now, he did not say whether it was all electric, fixed wing, VTOL, cargo, or passenger, but at least you see that even from the regulator viewpoint, they are talking about a near-term thing. He says, as we've seen before, they want to get to begin operations 2030, be in commercial service by 2024. So as you said, it's not far away. Next slide, please. So are they ready, or are we ready for what about from the regulators? Well, we've seen a lot of progress in the last couple of years. EASA has put out its rule for these vehicles, its special condition for VTOL, and it has published its, I think, first, maybe second set of means of compliance, which is how the manufacturers show that they meet the certification requirements. And there are companies like Lilium and Volocopter that are in that certification process, probably several of them in that certification process. The FAA is, there are kind of three ways it could do this. It's said that there are three ways. If it's a winged eVTOL, they would fundamentally use existing Part 23 Amendment 64 standards-based certification for a general aviation type aircraft with special conditions for those unique features that make it an eVTOL or an eSTOL or something like that. If the vehicle looks like a rotorcraft, which, for example, Jaunt's Journey does, then it could be Part 27 or Part 29, which is how we certify rotorcraft today. But it's likely that the initial ones at least will be certified under Part 2117B, which basically treats each aircraft as a class in its own right. It's a bespoke certification for that aircraft. It doesn't really help the next manufacturer certify the aircraft because they do it, but it's a way of getting a new class of aircraft certified into the market. Volocopter, for example, which is doing SC-VTOL certification in Europe, has announced that the FAA has agreed to validate the Europe's certification, and Volocopter says it will be under Part 2117B, that they will incorporate the FAA requirements into their test program and generate both sets of artifacts at the same time. Now, China's got off to an early start with EHang, and one of the reasons they've done that is they are using something that's called JARIS SORA. It's an internationally agreed framework for approving very specific operations by large UAVs. So if you look at a UAM type application, if you are doing a very defined operation where you can really define the risk, bound the risk, and mitigate the risk, then you can use SORA if its vehicle's not too big, you can use SORA to certify it. So for example, if you look at EHang, if you are going to be flying freight to the top of a mountain, if you were going to be flying tourists over the sea at a coastal resort, if you were going to be flying passengers just over the river in downtown Guangzhou, just literally take off, cross the river, land. If you can bound all the risks around that, mitigate all the risks around that, then China will say that we could probably approve you that, and that's why EHang thinks it can get certified this year. It's trying to take the same approach in other jurisdictions. It's just had a special flight permit in Europe using SORA. The jury is out as to whether the EASA or FAA will accept SORA for commercial operations. Anyway, next slide. And the reason that certification is so important is these are probably some of the most complex vehicles that we've ever brought to certification. We know that the Airbuses and Boeings worlds are very complex aircraft, but technologically, these UAM, AM vehicles are extraordinarily advanced. If you look at this Volocity, it has 18 rotors, 9 battery packs, and multiple redundant flight control systems. Joby's S4, 6 tilting props, 4 battery packs. It has multiple aerodynamic controls for cruise flight, and it uses this concept of unified flight control that was developed for the F-35, which makes the aircraft incredibly simple to operate. These are big steps forward. In UK Vertical, we saw it's very complicated. In Lilium, it wants to operate 36 ducted fans on 12 tilting flaps. It has no tail flight control. In this case, everything's done by the fans. The tilting, the throttling, provides everything. It provides thrust, lift, flight control. You know, these are incredibly cool, complicated vehicles. Next slide, please. So one of the big questions that's come up as we talk about certifying these complex vehicles is the level of safety. So, you know, how safe should these vehicles be if they're going to be carrying passengers commercially over cities? So EASA took the approach when it put out SC-VTOL. They created this thing called Category Enhanced, which is for commercial passenger transport and flight over congested areas. And basically, it says the aircraft must be able to continue, if it has a failure, a power failure or another failure, must be able to continue safe flight and safe landing. And what that ends up with really is a requirement that says that if there is the probability of losing the aircraft as a result of a catastrophic failure has to be greater, probability has to be less than 10 to the minus 9, which is the same level of safety as is applied to transport category commercial aviation. The FAA has been less clear, certainly publicly, in what approach it was going to take. But again, going back to what Jay Merkel said yesterday, you see the quotes there. In terms of AM, we view those as having the same level of safety as any other passenger aircraft or any other form of manned aviation. As a result, the FAA expects these aircraft will operate like any other Part 21, 23 aircraft with Part 91 operations. Now, the interesting thing is Part 23 is general aviation aircraft under 12,500 pounds, I think is where the limit is. Transport category is Part 25. Also, Part 91 is private operations. Part 135 is air taxi. Part 121, I think, is commercial operations. So if you were to take those at face value, it would say that the FAA is going to take a similar approach to level of safety as it does to general aviation, which would appear on the surface to be lower than commercial aviation. But my personal feeling, and the feeling I think of many people in the industry, since this is a global industry and the manufacturers want to be able to operate aircraft around the world, they will all probably gravitate to the highest standard, which is the 10 to the minus 9, the commercial aviation level. Also, if we ever want to scale this up to the densities of traffic that people have talked about, even 10 to the minus 9 is probably not good enough. We are probably going to have to, over time, get to a system level of safety, which includes lots of other factors other than just the vehicle, that is much higher than that, to avoid having, daily crashes with tens of thousands of vehicles around the world. So, but we are beginning to see what we're aiming for. Next slide, please. And this is this is a sort of my get off stage here, and we'll take some questions. I've talked about the technology. I've talked about the regulators. AM is incredibly. We are inventing a new form of aviation. We are deploying a new form of aviation. It's incredibly challenging. The next big challenge everybody will face is access to airspace. AAM can begin using existing helicopter routes and operations like airport shuttle services. It can then move into, and the FAA has put out its initial ConOps for this, it can move into using dedicated corridors to fly between vertiports, but that will not scale to the levels of activity that people want to see if this becomes a ubiquitous democratized service. It's similarly infrastructure. We can begin with existing helicopters. We can repurpose things like parking garage roofs into vertiports. We do need to start developing dedicated vertiports, and we've seen that with Lilium announcing its plans for Orlando. We also need to, and I would have said a year ago, 2 years ago, this was my biggest red flag, was community acceptance. If people are going to use this service, we have to engage with the community, not just public acceptance, but will the community allow these services? Will people want to use them? So we have to engage with the local governments. We have to become part of their transport planning. We are beginning to see that in a big way. In the last year, we've seen these manufacturers, Liliums, the Whisks, the Volocopters, all engage with communities across the world and start to do that planning process. There are large-scale demonstration programs that will help with that. NASA's national campaign here in the US and CESAR in Europe has just announced a multi-country large-scale demonstration program, which will help to socialize and understand how the community can embrace this. But I think now my red flag is now centering on the scaling up, because that really brings all these challenges together. We have got to, if we want to get to tens of thousands of vehicles carrying millions of people over cities at fares that make it accessible to everyone, we have got to dramatically scale up manufacturing. We've got to dramatically scale up infrastructure. We have got to find a way to open up access to airspace on a massive scale. We've got to find ways to operate these things. We've got to bring autonomy in to bring the costs down. We will never find enough pilots to fly these things anyway. So I think, all of these challenges come together when we start that scale up, which probably won't happen for a few years. We will see operations start. They'll probably be quite constrained, quite limited. They might even look a lot like current aviation operations. They might be in rural areas. They might be in countries where it's easier to get this started. But at some point or other, we have got to tackle that scaling up if this is really going to be the market we think it is. So at that point, I'm going to halt and I'm going to move over to here and I'm going to have a look at the questions. Oops, I went too far. So what about the role of hydrogen will play in the UAM market? We have at least one startup, Alakai, that is looking at hybrid fuel cell, hydrogen fuel cell. They plan to fly an actual full-scale demonstrator this year. We have got to take automotive fuel cells and make them aerospace grade. We've got to lightweight them. We've got to get the pound density up. We've got to get tanking that is aerospace lightweighted. I think it will probably start in CTOL airplanes first, like Universal Hydrogen or Zero Avia. But if we can get fuel cells on an aerospace track, then in some respects, they may be a better future than batteries in the longer term. And also, if we are talking about using green hydrogen, because we get away from using the grid to recharge batteries and we start to create green hydrogen for it, we do get to zero emissions. We talk a lot about the how, the technology itself is technically feasible, but how about the why? What is the potential market? I think that is really the unanswered question. It is easy to say that urban air mobility will alleviate congestion, but it only alleviates congestion if you get to urban air mobility on a vast scale. It doesn't do anything for congestion in the first scale. Also, you've got the first and last mile bit. I mean, if you're flying by UAM and you have to get in an Uber car to get your first and last, so you need the infrastructure to build out. So then you're getting into what about the regional market? Well, I do believe that over time, the regional market has moved away from connecting smaller cities over shorter distances. We now fly very large regional jets. We fly them to hubs. So I do believe that we've stretched that piece of elastic to the point where it could snap back. And if we can get the operating cost right for these shorter range aircraft, I think we could reinvigorate that. It does require the airline industry to change its business model, and I'm still not entirely convinced that is going to happen. But there are some Part 135 operators that are very excited about the possibility of growing into these markets. There are a lot of airports around that could be used. They would all have to be upgraded to commercial service. But these vehicles are quiet by and large, or quieter, and they are clean. So some of the issues around the use of these local airports might be less onerous if we're bringing electric types of vehicles in. A lot of it's going to do with the noise and other things like that. Yeah, business model for most civilian AM applications depend on massive utilization. These are the questions. I see now no barrier to operations beginning. I see cargo operations, regional cargo operations, rural cargo operations. I see airport shuttles. I see other types of operations. I see a clear road to those starting. But we have to get the cost down dramatically for it to scale. We have to get the accessibility up dramatically for it to scale, and we have to make it an everyday occurrence. And there are so many chickens chasing so many eggs around here that we have to start somewhere. And I suspect we start by driving the cost of the vehicles down, and we see whether that's enough to get the markets to start to pick up. But it all keeps coming around. If you don't sell enough, you can't invest to drive the cost around. It is a big question. I think one of the problems we faced with this is that we began this industry with Uber's vision, which was an end state at scale vision of urban air mobility. And we're fixated on that end state, thousands of vehicles flying millions of people tens of thousands, blah, blah, blah. And we've kind of focused on that, and we've got to think, well, can that ever happen? I can't imagine a future it doesn't happen, but I can't tell you when that future happens. So I think there's still a lot of unknowns between now and then. As I say, EASA and FAA working to harmonize. I think the Volocopter announcement is the first sign of the FAA and the EASA saying, okay, I think we know we can find a way to work here. I should point out that SC VTOL was based on, was grown out of EASA's CS23 requirements, which are harmonized with the FAA's Part 23 Amendment 64. And then the EASA took out of that the requirements it needed and added what it wanted for specifically for VTOLs. So I think that once the FAA has worked through its 2117B process with a number of applicants, it will have enough experience to say what it wants in a rule specific perhaps to eVTOL or yet another version of Part 23. So I think we will get there, and I think that the two know how to bridge the gap. It might mean it's a bit more onerous for the manufacturers. In the meantime, they will have to take account of two different sets of requirements, but a lot of it's common. They're both based on the Part 23, CS23 starting point. It's just how much does it deviate from there. The clear front runners, AAM, Joby, Lilly, and Volocopter, do you think these companies are likely to take the majority of the market? Room for future companies? They may take the majority of the initial market. I think that if we do get scaling up, because of the nature of the problem, because of the transportation problem in mega cities around the world, all of those mega cities are looking at how they meet their future transportation needs. They have to. So if AAM, UAM becomes part of their package of solutions to their long-term transportation problem, I think the market's big enough for quite a number of players. And also it might be of a different nature to the traditional aviation market, because a lot of these are planned to be manufacturers and operators. So, and there may be regional solutions. China may, EHang may dominate the Chinese market, but nowhere else. You don't know. But I do think that if we can scale, the market's big enough. If we can't scale, those early entrants will have a dominating position. Every photo provided by the company shows an aircraft in clear weather. Yeah, no, you're absolutely right. There is no doubt that everybody is thinking of starting in VFR. Again, it's a crawl, walk, run, as everybody talks about this. The FAA, Jay Merkel, did say that they are having discussions with people who do want VFR at night and people who do want IFR in weather. It's probably going to be a go fly, go get the experience, go get the data, come back and tell me, and then we'll talk about it. We are, if you want to de-ice these vehicles, we're going to have to have the energy capacity for that. So, we have to get the batteries to a point where we can do the baseline mission and provide all the power to do all the rest of it. A lot of it's to do with the infrastructure. You are going to have micro weather, right? We are talking here about in a city. We are going to have micro weather. So we're going to have incredibly granular weather data, which we don't have at the moment. We're going to have really good connectivity to the vehicles, really good surveillance and navigation for those vehicles. So I think that there is a path to get there, but it's not just about jumping into the market with an all-weather vehicle, which means you are going to have to look at markets where you can get some level of schedule service reliability with the weather that exists, but it may not be all times of day, all types of weather, at least initially. And again, that depends on how you condition the market to what the service you are offering. If you go into the market, saying that you will always be there to carry somebody, and then you keep canceling flights, they're not going to have a good experience, and you're not going to have a good business. So I think those two things are going to go hand in hand. So how are we doing, Becca? We got a few more minutes. Has Becca fallen asleep?
I mean, you can stay for another minute.
Could you put the slide back up for me, please?
Yeah.
and advance it to the next slide. Oh, that right. So the one after that, that's me. Okay, so I wanted to just finish off. It was just about the risks of this market, and some of them we've brought up in the questions. So the biggest risk is the market doesn't exist at all. Nobody wants to fly in an air taxi. Nobody wants to get from their farm in the country to the city or commute from the suburbs by aircraft. That's a possibility. We are still early in the days of we are developing an aircraft, we are developing an operation, and we're also developing a market, and we're in the early stages of all of that. The market could exist, but it could stay a typical aviation market, like helicopter market of a few hundred units a year. That's not what people hope it's going to be. It's also not really great for the aviation market because it would just eat away at existing markets without necessarily providing huge volumes, and the vehicles would be expensive, and we wouldn't see this proliferation and democratization of aviation in a way that people think can happen given the technologies and should happen given the challenges of transportation. The market could be huge, but it could be an automotive market, not an aerospace market. It's absolutely clear the automakers are fascinated by this market. They're all recasting themselves as mobility providers. They're all going into self-driving cars, ride-sharing, tie-ups. They want to, if people aren't going to buy cars, and if they're not going to keep taking their gasoline-powered cars to the shop to get repaired, they have to look at their future revenues, and their future revenues is from moving people around. So they see air mobility as an integral part of their future mobility offering, and they also have the ability to make it truly multimodal, which I think is a real crucial key here. And I mean, and this is, it's not to be unfair to the Chinese. You've got to be admired for their speed of adopting new markets. But we saw it with the drone market. There is definitely a market for drones, but in the developed aerospace industries, developed aerospace markets, US and Europe, they were largely ignored. The FAA didn't know what to do with them. The DoD wasn't interested here in the US. As a result, the volume market, the initial consumer market, went to where there was a market, and that became the roots for the commercial market we now know as the commercial drone market. And so the risk there is that if we don't pay attention to this market, these technologies will that will just migrate to a market, to a country where an environment where they can thrive. And so that's what's behind the US Air Force's Agility Prime program. It's explicitly about engaging with the emerging industry early, helping them get to FAA certification by providing expertise, testing assets, test sites to fly their aircraft, military airworthiness approvals as a step towards FAA certification, and then identifying military requirements that could justify early procurements to get those production lines running. They're aiming to be able to do that by about 2023, which is when everybody wants to have their production line starting to move. And it could be for logistics, it could be for base security, it could be for some other market, but they're trying to avoid what happened by drone. They're trying to actively engage, encourage, by doing that, bring investors in so that this industry grows up here in the US, and obviously in Europe it's already got a bit of a start through some of the startups that were really got started in Europe. And so at that point I'm at about plans to wrap up. So I want to thank Rebecca. Thank you very much for being my producer. And folks, I would please ask that you let us know what you think of this. This is the first time I've tried to do this, and I'd like to know whether it was valuable, and also whether we should do more of these. There are many other technologies with wide implications for aerospace: electric propulsion, hydrogen, autonomy, artificial intelligence, orbital debris, you name it. I'm just, let us know if you'd like us to do something like this on some of these other topics, and whether you'd find them valuable. So on that, I'm going to sign off again. Thank you, Becca, and hope everybody has a great day.